Hello, I'm Ekin. In this video, I will explain step 10 of our wireless network lab using Omnet++ and the iNet framework. Step 10 has three parts, A, B, and C. Let's start with part A, which is static routing based on error rate matrix. In this scenario, we built a completely wireless network. There are a total of 7 nodes in the network from host 1 to host 7. Each node is connected to the network via its VLAN 0 interface and they are all assigned IP addresses. The main purpose of this scenario is to simulate a network where routing tables are statically configured. Routing decisions are made based on a predefined error rate matrix. For example, if host 2 wants to reach host 7 and there is no direct link, it uses an intermediate node with the lowest error rate as a gateway. Let's run our simulation. We can clearly observe this in the routing tables. Each node has a routing table that shows how to reach other IP addresses, through which interface and, if needed, via which gateway. For instance, host 2 reaches host 5 through host 3, which acts as a relay. Thanks to this static setup, every node knows the best path to its destination from the beginning and does not change routes during the simulation. This approach works efficiently in small and stable network topologies. However, one disadvantage of static routing is that if a node fails or the topology changes, the routing tables won't update and communication can break down. The routing table is very important. Therefore, step A is suitable for networks where the structure does not change frequently and routing overhead needs to be minimized. During the simulation, we can observe matrices such as throughput, end-to-end delay, and packet loss. These metrics can later be compared with dynamic protocols like AODV in future scenarios. This concludes the explanation of step A using static routing. Let's get to the step 10b. Part B is unconfigured routing tables prepared for managed routing. In this scenario, we still have a completely wireless network with 7 nodes from host 1 to host 7. All devices are connected using their VLAN 0 interfaces and or assigned IP addresses. However, unlike step A, no routing tables have been configured for any of the nodes. Those are our routing tables from host 1 to host 7. As we can see in the log simulation, all routing tables are empty. This means the nodes do not know how to reach each other, and no static paths have been defined. This type of setup is typically used as a preparation stage for managed protocols such as AODV or DSR, where nodes dynamically discover routes at runtime instead of relying on preconfigured static paths. Let's run our simulation. Since there are no routes, we can observe that no data is being exchanged between the nodes. Even if we try to send a packet, it won't be delivered because the sender has no information about how to reach the destination. This shows the importance of having a routing mechanism in dynamic wireless networks. In later scenarios, we will introduce dynamic protocols like AODV, which will automatically generate routing tables based on route discovery processes. So to summarize, step B demonstrates a wireless network in which routing is not configured, and it's ready for minute-based routing algorithms to take over. Let's get to the final part of our wireless network lab, which is step 10C. Part C is routing tables configured using AODV protocol. In step C, we are now using the AODV routing protocol, which stands for Ad Hoc On-Demand Distance Vector Routing. This protocol is commonly used in managed or mobile ad hoc networks. Just like in the previous scenarios, we have a fully wireless network consisting of 7 hosts, all connected via their VLAN 0 interfaces and using IP addresses. Unlike static routing in step A and unconfigured routing in step B, AODV dynamically builds routing tables only when needed. Initially, if we check the routing tables for each node, those are our routing tables, we see that all routing tables are empty. That's because AODV only creates a route when a node wants to send data. So now, let's generate some traffic between nodes. Let's run our simulation. As soon as the communication starts, AODV performs a route discovery process using route request and route reply message to establish a path between the source and destination. As you can see in here, once the route is established, packets can flow between the nodes. If a link breaks during transmission, AODV will automatically detect it and attempt to find a new route. This dynamic and reactive behavior makes AODV very suitable for highly mobile and frequently changing network topologies, such as in military, disaster recovery, or vehicular networks. In conclusion, Step C demonstrates the power of on-demand routing protocols like AODV in building efficient, flexible paths in wireless environments. Thank you for watching.